So normally when we discuss geology, we're talking about processes that take millions if not billions of years. And that's because on Earth this involves cycles that are extremely slow and are very difficult to observe on human scales. For example, we have sediments that gets buried, gets compacted, and slowly cemented over eons as it transforms into some kind of a new mineral, thousands of which have developed on Earth in the last 4.5 billion years. And though for the most part Earth's crust is composed of silicate minerals, including quartz, feldspar, olivine, and mica, we also know that in the last 4 billion years, at least 2/3 of all minerals on Earth were actually created as a result of life, either directly or indirectly. Nearly 4,000 mineral species have been created as a result of various oxygenation reactions and as a result of biomineralization. And that actually includes over 90% of uranium-based minerals and even minerals containing nickel, cobalt, and molybdenum. And obviously all of the carbonate minerals like calcites were also formed by various types of life. But once again, these are processes that are pretty slow and take at least a few millions of years. Except that recently researchers discovered something that was officially created by humans and surprisingly happened pretty fast. Here researchers discovered something that might actually require us to rewrite textbooks on geology. It turns out that completely by accident, humans created a kind of a fast-track geology, forming a new type of a mineral in just 35 years. And here this is not just some kind of a curiosity, this is a new scientific classification for what now is referred to as anthropoclastic rock cycle. Something that was thoroughly explored in the study you can find in the description. And so today we're going to discuss some of these new discoveries and talk about these human-made rocks and discuss the science of how they are able to form so quickly and what this means for our understanding of Earth's history, and specifically the newly proposed Anthropocene epoch, something we've already discussed in one of the previous videos in the description. But one of the most recent and perhaps the most startling discoveries came from a coast of England, and specifically a place you see right here, the Derwent Howe. And so here a team led by Dr. Amanda Owen from the University of Glasgow discovered that the shoreline there is no longer formed by loose pebbles and sand. Instead, they discovered something entirely different. Here they found glassy blue-gray cliffs and hardened platforms made of what looks like natural rock. But this is not natural sandstone. It's actually what's known as steel slag, waste material from various industrial furnaces that have eventually fused into a lot of this solid stone. And that's because for approximately 200 years, industrial activity in England, and especially at this site, dumped a tremendous amount of waste, depositing it in the soil, with the ocean waves then sculpting this waste and cementing this inside the rock. But I guess one question here is, okay, but how do we know this is what happened, and if this happened fast? Well, geologists don't just guess. They look for what's known as index fossils, or markers. And in this case, the markers weren't trilobites or dinosaur bones, and instead they were actually pennies. You can see them in this image. These were King George V pennies from 1934, and even more specifically, an aluminium pull tab from a can that was only launched in 1989. But because these objects were found inside rock, and specifically inside solid rock, scientists can now confirm that none of this took longer than 35 years. Once again, because the youngest object was from 1989. And in geological terms, this is essentially instantaneous. And there are quite a lot of images you can find of this on the web, showing us how the rocks in this region look entirely different. And so here we have a lot of examples of industrial waste literally becoming rock. But I guess the question is, how? How does a pile of industrial trash become a cliff in just 3 decades? And that's of course quite a big mystery, because normally, in natural sandstone, grains of sand must be buried deep underground first, and they then have to be squeezed by pressure before they slowly get glued together for millions of years. And well, the answer seems to be that glue. In this anthropoclastic rock cycle, the glue seems to be pre-mixed in the waste. And mostly because a lot of stuff that was deposited here already contained many of these particles. And specifically when the team from Glasgow analyzed the section of the rock and used tools like, for example, X-ray diffraction and Raman spectroscopy, they discovered a lot of familiar minerals, calcites, brucites, and goethites. And these are actually exactly the same minerals you usually find in a regular sediment that were already forming here as well. But the difference is the starting chemistry. In a typical steel slag, it's actually already chemically primed for the cement growth. And so when it reacts with seawater and the atmosphere, it generally creates rapid chemical bonds that then mimic natural lithification. Or basically they kind of look like natural rock formation, but at extremely fast scales. With this process then turning sediment into stone thousands and thousands of times faster than in nature. But turns out that this is not just happening in England, although that part is maybe not very surprising. This is now happening pretty much everywhere. But right now, a survey of 14 British sites already found approximately 76 miles of these coastal slag deposits that have been officially confirmed. But they've also been spotted in Baltimore and in Bilbao in Spain. And the thing is, it's obviously not getting any better. Steelmaking now produces approximately 2 billion tons every year, which then results in approximately 400 million tons of slag. And all of this gets deposited somewhere. And turns out that all of this steel slag then starts to form these rocks in just a few decades. Although I guess just to clarify, steel slag is basically a byproduct of steelmaking that usually separates molten steel from impurities. And so at the end it usually forms a kind of a silicate and oxide-rich material that then becomes solid once you cool it down. And though sometimes it can be used in constructing roads and in even making concrete, for the most part it just ends up like this. It's just dumped somewhere and left alone. But it's not only about metal slag, or basically it's not just about steelmaking. Because turns out humans have accidentally found another way to make a different type of minerals. And you might guess what's in it. Plastic. So we now have a new thing called Plastiglomerates. Literally a rock containing a lot of plastics. And this was first documented on Camilo Beach in Hawaii only in 2014. And so basically these are rocks where plastic waste, for example fishing nets, ropes and containers, start to act as a binding agent and create their own mineral as a result. And when this plastic is melted, for example by campfires or even volcanic heat, it then flows into gaps between sand, seashells and coral, mixing everything together and literally creating a new type of mineral. And so once everything cools down, it essentially creates a kind of a junkyard mixture. Something that's a lot denser than normal plastic, and also something that's pretty heavy. And because it's heavy, many of these Plastiglomerates eventually sink to the seafloor, where they can then significantly increase the chance that they're going to be buried and preserved in the geological record. And so here scientists like Patricia Corcoran discovered these unusual minerals at pretty much every site in Hawaii, with this report in 2020 officially coining the term. But since then they've been reported in most locations on the planet, including Indonesia, Brazil and Japan. And so even though this was the first official site, they've now been confirmed to exist worldwide. And this is officially becoming a kind of a global marker for that previously mentioned Anthropocene, a proposed geological epoch defined by direct human impact on planet Earth. And so in pretty much all cases here, this is something that's formed by human activity, and in this case plastic waste that was melted over time, that once again starts to somehow cement surrounding natural materials, but in this case doing so extremely quickly, eventually resulting in these unusual rocks. And we now know that this can actually form naturally, where plastic pollution can then meet some kind of a heat source, such as lava flows or forest fires. Which is why it was discovered in Hawaii, very close to volcanic activity. And so because of their durability and high density, researchers now believe that these are basically technofossils. They're extremely likely to persist for millions, if not billions of years, serving as a kind of a permanent physical signature of human pollution. And though it is quite possible that some of this might convert to something else, even reverting back to oil form, this still doesn't change the fact that this is an incontrovertible evidence of human presence. With this type of a mineral even having its own subforms now, such as plastic crusts and plastistones. Basically slightly different formations depending on how they were formed and what's inside of them. And that's of course a really important reminder of something else. Plastic pollution has now reached pretty much everywhere, even the most isolated ecosystems on planet Earth. And we actually recently discussed some of the more dangerous parts of plastic pollution in one of the videos about human health that you can find in the description. But I guess the question is, so is this a problem though? Especially because this is basically maybe one potential solution to that plastic problem. Maybe by turning this into rock and by creating more plastic minerals, we can start solving the problem of plastic pollution on the planet. I mean, for all we know, maybe we can take a bunch of these rocks and then create some kind of an island somewhere. Hey, more land, more real estate, right? But the real answer is a little bit more complicated. And that's because a lot of these rocks also change the way coastlines work. For example, those metal-based rocks, or the slag aprons, generally change how waves reflect and how sediment moves in the ocean. And that can actually cause faster erosion on a lot of natural cliffs nearby. On top of this, there's also the obvious chemical component. Many of these rocks will contain something toxic inside. For example, toxic metals like chromium and vanadium. They can also create what's known as an alkaline halo. They essentially raise the pH level inside water, and that makes water more basic, which can then stress local wildlife and affect a lot of wildlife living nearby. Now, the actual effects have not been established yet, and this has not been studied that well, but there is a slight chance that it could be more hazardous. At the moment though, it's kind of unknown. But on the positive side, some engineers started looking at these rocks as potential sources of carbon sinks. And that's because in many cases, various chemical reactions, the reactions that actually create the stone, can also absorb carbon dioxide more efficiently, thus reducing the levels of CO2. But here we have to be careful obviously, because we don't really want to trade the carbon dioxide problem for a toxic beach problem. So this is something that has to be investigated in some of the future studies. But because many of these discoveries are essentially brand new and we're just learning about this, at the moment there is not much else that's known. I mean, we definitely have evidence of this rapid anthropoclastic rock cycle, the cycle that turns industrial and plastic waste into solid stone in just a few decades, but we don't really know what effect it's going to have on the planet, and whether this is good or bad. We just know that this confirms that humans are definitely actively reshaping the planet, while also officially adding this little bookmark into the book of geology of planet Earth. And so here we have rocks that prove our industrial materials do not just sit in landfills, they do enter the rock cycle, becoming a prominent part of the Earth's crust. But here it would be interesting to discover how quickly nature adapts to all of this and how it's able to incorporate all of this waste into its own natural processes. And so that's actually something we're going to be examining next once there are some additional studies. Until then, thank you for watching, check out previous videos on plastic in the description below, subscribe, come back tomorrow to learn something else, support the channel on Patreon where you can find additional videos without any ads, and can DM me directly, or by joining a channel membership that grants you early access. You can also support the channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.